Hello, honors people. So I'm going to make a quick tutorial of what we did in class, so that way you can recreate it and do it by yourself at home in case you didn't take notes or you just forgot a couple of the steps. So I'm going to redo part 1, which was the steel wool being pulled apart. All of this is the class data, right? So in science, we want to make sure that we have many trials, a whole bunch of data points, because if we just do it one time, if we do an experiment just once, that doesn't tell us anything. That doesn't prove that it happens consistently. So that's why we collected all of the trials from all of the periods, and we compiled it onto this Google Sheet. And on this Google Sheet, there is, for part 1, there's 36 different data points. And so we want to do the easy way. We don't want to calculate the change in mass, every single one by hand. We don't want to do that with the average or the median or anything else. And I think I misspelled average, so I'm going to correct that really quick. Okay, so in order to get mass change of something, we want to subtract the initial mass minus the final mass. And so what we're going to do for that in Excel, or this is Google Sheets, not Excel, we're going to press the equal sign. So whenever you want to make an equation, whenever you want to calculate something in Google Sheets or Excel, you always start with the equal sign. So equal sign, and then open parentheses, we're going to click the initial system of the mass. So we're not going to type the number 4, we're going to click the actual cell, and so our cell is E2, and we're subtracting it from our final system mass. So we're going to click that F2 cell. We're going to end the parentheses and press enter. So 4 minus 4 equals 0. That makes sense. Alright, when you click on the cell again right here, so we're clicking on G2 cell, there's a little blue square that appears on the bottom right of it. We're going to hover over that blue cell, or that blue box, and there's a little cross sign or a plus sign that appears when we hover over it. We're going to click it, and we're going to drag that all the way down to our last row of data. So it just calculated all of the mass changes for every single group that collected data, right? 0.14 minus 0.135 is 0.005. All of these make sense. So it just subtracted 36 data points in 2 seconds instead of us doing it by hand. All right. So next, these are all just random numbers. They don't really look very pretty to us. So I want to sort these from lowest value to highest value. So how we are going to do that is hover over G, and there's a little arrow that appears. That's going to give us a drop-down menu. Under this drop-down menu, we're going to scroll to where it says Sort Sheet A to Z. And so we want to sort from the lowest value to the highest value. So we're going to sort it from A to Z. Right, so this is a low value, negative 0.05, and it scrolls all the way down to 0.03. Now if you notice, column H has completely been messed up, so I'm going to highlight that whole column by clicking on H at the top. I am going to press backspace or delete to get rid of all the words because all the words are out of order. I am going to then change the background cell colors by clicking on this little paint bucket right here. And then I click on white just to get rid of all the red. And if you notice, some of the cells are boxed in. If you click where it says borders and there's a little checkers right there, and then this one right here, you're going to unclick the boxes. So now everything looks pretty, it's reformatted, and we're going to go ahead and calculate the average. So average, again, I want mine to look pretty, so I'm going to color that background cell red. You can color it whatever color you want, but this is just to keep me organized, so I know that whatever I type, whatever's below it in that colored cell, corresponds to that word. Alright, so in order to calculate average on Google Sheets or Excel, we're going to press the equal sign again. We are going to type average in all caps, open parentheses, and we want to calculate the average of all the different mass changes. Right, so all the yellow columns. So we're going to click on G1, and we're not going to unclick it, so click and then drag all the way to G36. So your equation should look something like that. We are going to put an end parentheses and we're going to press enter, and that is the average of all our data points. Alright, next we want to calculate the median. Again, I'm going to change the background just so I know what it is for. Alright, our median, same thing. We always start with an equal sign when we're calculating something. We are going to type median in all capital letters, open parentheses, And again, we are going to click on all of the data points on the yellow column, G1 through G36, and then close parentheses, press enter. And so our middle number, our median, is 0.015. All right. Next, low median. Again, I'm going to highlight the color of the cell, choose whatever color you want. So the low median is getting the median, so we're going to type the same thing, equals median in all caps, open parentheses, but the low median means we're taking the median of the bottom part of the data set, of the lowest numbers of the data set. So all of our low numbers are right here, right? Negative 0.05, 0, and 0.005, 0.01, right? These are all of our low values. And if we look at all of our data sets, there's 36 total data sets, right? If you look at the row 36, there's 36 data points. That means that our bottom half of the set with all the low values is half of that data set, right? So G1 all the way to G18, right? So 36 divided by 2 is 18. So the first 18 data points on our Google Sheets, that is the bottom half of our set. Those are the lowest values. And so in order to calculate the low median, we want to highlight G1 to G18. And then we're going to end that parentheses and press enter. So that makes sense, right? 0 seems there's a lot of zeros. So if we go back and forth through the 1 through 18, we're going to get 0 as our median. All right, our high median, same thing, right? So we're going to highlight the cell color, equals median, open parentheses. And the high median means that we want the median from the top half of our data set, from the biggest values in our data set. And so we're going to start at G19, which is right here. And we're going to click and drag all the way to G36, right? These are all the biggest numbers in our data set. So 0.02, sorry, all the way to 0.3 in this case. And we're going to end our parentheses and press enter. Oops. And our high median is 0.055. Which I would say makes sense because that would be right around here, and that looks like it's kind of in the middle of that top half of that data. All right, next one, we want to calculate the lowest value. Again, I'm going to change the color of the cell. All right, so this one's really easy. We sorted this sheet already from A to Z, so our lowest value is the top right here, G1, and our highest value is 0.3. That makes sense. So instead of copying and pasting it, I'll show you an alternative way to copy and paste. Instead of typing it, this is an easier, quicker way. So I'm going to press the equal sign and then just click on that cell and press enter. So I just copied and pasted it for me. So that's the lowest value. And the highest value, we're going to do the exact same thing. All right, so we're going to press the equal sign. We're going to click on our highest value, which in this case is 0.3. That was the biggest number that we got. That was the biggest mass change that we got. Press equals, and it just copies and pastes it for you. Alrighty. Alright, so let's go over what a box and whisker plot is really quick. So that way you guys all know all the words, all the vocab, and how to set one up based on what we just calculated. So I'm going to change my color here to red really quick. Alright, so on our box and whisker, this bottom whisker is our lowest value. The top whisker is our highest value. The middle part of the box, that is our median, so just a normal median from our whole data set. The top part of the box is our high median, so just the top part of our data set. And then the bottom part of our box is our low median. So the bottom part of our data set. So we're going to recreate a box and whisker plot based on what we just calculated in Google Sheets. Alright, so this is based on our data, right? So I have this negative 0.05, that was our lowest value. 0.3 was our highest value. And then I drew the box over to the left because 0 is closer to negative 0.05 and also the median 0.015 and the high median, which is 0.055, right? So these are all really close together, Whereas this one over here, this 0.3, it's not really close to any of these 0.0 numbers, right? And so this is our outlier, right? So right here, I'm going to change the color again. I'll do pink this time. This right here, our whiskers are called our outliers, right? Even on the lower end, this is also called an outlier right here. And then everything within this box, that's considered like good data, so to speak. That means you are within the average of the class. And our average should fall within this box. And so if you did something wrong, maybe you measured the mass wrong, or maybe you read the balance wrong, maybe you lost some of the steel wool, right? There could be a number of different reasons. You didn't record it down correctly. Whatever the reason is, the reason we take all of the data sets together from all the classes, all the periods, all the groups, and put it into a Google Sheet and analyze it is to make sure we have good data. Because if your group messed up something, whether on purpose or by accident, whether you knew it or whether you didn't know it, if we analyze it as a whole class, as a whole group, we now know what is considered valid, what is considered accurate, what is considered precise, so to speak, and what is not, right? And so in this case, if your data fell between 0 to 0.055, I would say you're pretty good with the rest of the class, with what everyone else has been getting. And so how we analyze this is we look at this box right here. And I would say, yeah, it increased maybe a tiny bit in mass, right? The steel wool maybe just a tad bit increased. But for the most part, 0.015, 0.055, those are really close to 0. Really close to 0. So I would say that the mass didn't change very much. Right? It didn't change very much. So that is my interpretation of it, right? So when I get data, when I'm collecting data and I put it into Google Sheet, that is my observation. That is a quantitative observation. I'm measuring something and I'm going to put it into a data table. That is a quantitative observation. When I go ahead and do the calculations and in Google Sheets with the averages and the medians and subtractions, and I make the box and whisker plot, the graph, that I would say is analysis, right? So an analysis is you're trying to get that data and you're analyzing it to make more meaning of it, because numbers are just numbers. We have to do something with it. We have to analyze it. We have to make graphs. We have to do statistics with it in order to make sense of it, because otherwise it's just a number that we don't care about. And then last but not least, once you've made your statistics, once you've made your graph, your box and whisker plot, you have to interpret what that is trying to tell you. Again, this box and whisker plot, this is just random numbers, right? You make sense of that. You are the person who is trying to figure out what is actually happening with our data. And so that would be considered an interpretation. So mass didn't change very much. That is an interpretation, right? And I would say that's pretty accurate, right? Steel wool, when you keep it really clumped together. So I'm going to draw some particles of steel wool. There's 1, 2, 3, 4, 5, 6 different particles, right? This is the steel wool being all clumped together. And then we stretched out that steel wool. We made it bigger. 2, 3, 4, 5, 6, right? We stretched it out. The only thing that changed, where'd my dot go? There we go. The only thing that changed in that instance, I don't know why my dot keeps disappearing, you guys. There's a dot there. Okay. The only reason why my mass didn't change right there is because the number of particles didn't change, right? So we stretched the volume, right? We made the particles go further apart. There's more space between them. But the number of particles didn't change, right? We didn't change anything about the steel wool. We didn't get rid of any steel wool. We didn't add any steel wool. We just stretched it out. And so the mass didn't change. So the number of particles stayed the same because the mass stayed the same, but the volume increased because that's what we physically did to it. Right? So this is considered a physical property, which we'll understand later in the school year. Right? I hope this tutorial helped you guys with your homework. Let me know if you have any more questions. We'll discuss it again in class.